Good morning sir, I am Dona Spanna studying 9th class from core branch, and today I am going to demonstrate about motion. So first of all, what is a motion? An object is said to be in motion when it changes its position from one place to another place along with the time, then it is said to be in motion. So now I will show you a practical example about motion. So this is a ball, and if I make it move like this, it stops at particular point. So the started point I will name it as point A, and the ended point I will name it as point B. So here the ball is changing its position from one place to another place, that is point A to point B. Along with the position, the time is also changing. So the ball is undergoing motion. Okay. So once again, what is motion? An object is said to be in motion when it changes its position. Or simply, if an object is moving, then it is said to be in motion. So this is about motion, and I think you are all heard about the statement that is motion is related to the observer. So it means motion changes depending upon the observer. I will say an example here. So two persons are standing at bus stop and a bus is moving in front of them. So a bus is moving in front of them. It is going in east direction. So these two people are talking to each other that the bus is at motion and the passengers and the driver are moving along with the bus. So in their point of view, they are thinking like this, and in passengers and driver point of view, they are thinking that they are at rest and the two persons standing here are moving towards west. Why I am saying west here? Because the bus is moving towards the east. They are thinking that the people are moving towards the west direction. So here motion changes depending upon the observer. If the observer is in the bus, it is in one way. If the observer is outside of the bus, it is in another way. So motion changes depending upon the observer. So motion is relative to the observer. So there are some common terms related to the motion. They are distance and displacement, speed and velocity, and acceleration. By doing an example, we will discuss all of these. So let us start doing this example. Okay. So this four sides is covered by road. So this is road, and the breadth of this road is 30 meters and the length is 40 meters, and this middle place is occupied by the park, and here there are two persons standing, and here is the school. Assume this as school, okay? So these two persons kept a competition that who will go to the school firstly, they are the winners of that competition. So they kept a competition, and I will name this person, first person, as person A, and this person as person B. So they started their race, and the first person took this way. From here he started and here he ended. So he took this way, and now we will find the total length covered by him. So to find the total length, if we add this breadth and length, then we will get the total length. So 30 plus 40 is equal to 70 meters. So he travelled 70 meters. So that 70 meters, that total length is nothing but distance. because the total length covered by a body in certain interval of time is called distance. So that time, by how much time he reached the school, I will say it later, but now we will calculate the person's B route also. So the person B took shortcut, which is displacement, because the shortest way traveled by the person B is displacement. So he started from his initial point here and ended here. So this is the displacement, and now as we calculate the distance, we will also calculate the displacement also. To calculate displacement, what we will need to do is, as this is a right angled triangle, this is a right angled triangle, so here we can apply Pythagoras theorem. By doing Pythagoras theorem, we can find out the total length covered by the person B. So we will find out the displacement here. So this is a right angle, and what is the formula of Pythagoras theorem? That is AB square is equal to BC square plus CA square. Now here we will point out the, we will write the names of the points. So A, this is point B, this is point C. So here we need to find out the hypothesis AB. So AB is equal to, if the square 2 comes to right hand side, it becomes root of. So root of BC whole square plus CA whole square. Okay. So here AB is equal to root of, so what is BC here? That 40 meters. So 40 whole square plus what is CA? 30. So 30 whole square, that is equal to 40 whole square is equal to 1600 plus 30 whole square is equal to 900. So if we add the 1600 and 900, we will get 2500. So AB is equal to 2500. Root of 2500 is equal to 50. So we got the AB length. So person B travelled the displacement of length 50 meters. So he travelled 50 meters. So now I will say by how much time they both reached the school. So I will say the time. So person A travelled 70 meters in 100 seconds, and whereas person B travelled 50 meters in the same 100 seconds. So by saying this, immediately you may get doubt that why, even though the person B's displacement is less, then why didn't you won in this competition? You may get doubt. So that is, there is a variation in speed. So there is a variation in speed. So the speed of the person B is less. So he didn't won in this competition. So now we will calculate the speeds of both person A and person B. So firstly we will start from the person A. Before calculating speed, first of all, what is a speed? The rate of change of distance is called speed. So see here, we will calculate the person A's speed. So speed is equal to formula. Speed is equal to distance by time. So speed equal to, what is the distance travelled by person A? That is 70 meters. So 70 by, what is the time taken to complete his race? That is 100. So 70 by 100 is equal to 0.7 meter by second. Why I am writing meter by second here? Because the unit of distance is meter and the unit of time is second. So the speed he took to complete his race is 0.7 meter by second. Now we will calculate the velocity. We will calculate the velocity for the displacement of length 50 meters. So velocity or speed both are same, but for displacement we will calculate in velocity and for distance we will calculate in speed. But speed and velocity both are same. So we will calculate here. So velocity. So what is the formula of velocity? That is displacement by time. So displacement by time here. So velocity is equal to, what is the displacement traveled by person B? That is 50. And what is the time taken to complete his race? That is same 100. So 50 by 100 is equal to 0.5 meter by second. Here the unit of displacement is meter and the unit of time is second. So overall person A traveled 70 meters in 100 seconds with a speed of 0.7 meter by second, and person B traveled 50 meters in 100 seconds in the same 100 seconds with the velocity of 0.5 meter by second. So they both came at a time. So by this example, we understood the definitions. We can define what is distance, displacement, speed, velocity, and we did some of the problems. So now here I will say you about acceleration. So what is an acceleration? But before going to the acceleration, I'll just start with an example. So acceleration. So while we are traveling in a car, when the driver presses that accelerator, which is means it is used to increase the speed or velocity. So when that driver presses that accelerator, we can just experience that acceleration. We can just experience the jerk. So a body has acceleration when the velocity changes. So simply a rate of change of velocity is called acceleration. In acceleration, we have two types of accelerations. So positive acceleration, so which is positive acceleration, and negative acceleration. So what is meant by positive acceleration? When the velocity of a body increases with respect to the time is called positive acceleration. For example, so the velocity of a car is steadily increasing from 30 km per hour to 40 km per hour in 1 second, and then 40 km per hour to 50 km per hour, and so on. So here the velocity of the car is changing steadily from 10 km per hour. So this is positive acceleration, which will be increasing. So then what is negative acceleration? This is quite opposite to positive acceleration. So here the velocity of the car is steadily decreasing from 30 km per hour to 20 km per hour in 1 second, and then 20 km per hour to 10 km per hour, and so on. So here the velocity of the car is decreasing. When it decreases, then we call it as negative acceleration. And now we will discuss about the types of motion. So motion has two types of motion, that is namely uniform motion and the second one is non-uniform motion. So first of all, what is uniform motion? An object is said to be in uniform motion when it travels equal distances in equal interval of time. For example, see here, this is ground and here is the car. So here is a car and it is traveling equal distances. So for 1 second, for every 2 seconds, we will take 2 seconds. So for every 2 seconds, it is traveling 4 kilometers. So for example, so first it started at point A. So this is point A, and after 2 seconds, it is at point B with the total kilometers is 4 kilometers. And again after 2 seconds, it reached point C with the kilometers 8 kilometers, with the length 8 kilometers from the origin. And after again 2 seconds, it reached point D with the length, with a distance of 12 kilometers. See here, so the car traveled equal distances. So if you minus this 4 kilometers minus 0 kilometers, then we'll get 4. So 8 minus 4, 4. 12 minus 8, 4. So it is traveling equal distances in equal interval of time. So the time is also equal here. So in this case, we can say that the car is in uniform motion. Okay. Next, non-uniform motion. What is non-uniform motion? So an object is said to be in non-uniform motion when it travels unequal distances in equal interval of time. Then we can say it as non-uniform motion. See here. So take the same car example. So this is point A. So a car started from point A and after 2 seconds it reached point B with 3 kilometers, and again after 2 seconds it reached point C with the kilometers 7. So with a distance of 7 kilometers from the initial point where it started, and after again 2 seconds it reached point D with the distance of 19 kilometers. So here the car is traveling unequal distances. So if you minus here, then it will be unequal. So but in equal timings. So the car is in non-uniform motions. So this is about the motion. So in this video we discussed it about the motion and the statement the motion is related to the observer, and next distance, speed, velocity, displacement and acceleration, types of acceleration, positive and negative, and we also discussed the motion types of motions, uniform motion and non-uniform motion. So this is all over the motion lesson. Thank you.